Hello everybody, this is Zero Day, and this is the exploit SSRF with Gopher for GCP initial access scenario. Yeah, it's the title of the scenario kind of gives it away. Anyways, we have a web application that we have access to, and the web application is vulnerable. It has a very bad vulnerability. I'm sure you guessed it. It's server-side request forgery, SSRF. And because the deprecated Gopher protocol was still supported by the web application, we could use that Gopher protocol to access the metadata service on the compute GCP VM. So once we get access to the service account, we are then able to access a bucket that the web application talks to. So within the bucket, there was some interesting files, and that concludes the scenario. So let's jump right into it. We were provided an IP address and nothing else. There is some scenario information. It says in scope is their on-premise and cloud environments. We need to get initial access to their infrastructure starting with an identified IP address. So somehow we need to get access to their infrastructure. Let's just copy this IP address and see what it is. So let's paste the IP address here. It looks like the exact same website as the first challenge that we did in the previous video. There is contact us, about us. Again, seems static. But if we click on shop, this time it's new because shop did not work in the previous video. So we now have this, looks like a clothing store. Let's just interact with the application normally, just as we would in a web app pen test. I recommend when doing a web app pen test that you just interact with it as a normal user, and then you can look at all the different endpoints that you are querying in the HTTP history of Burp Suite. So let's just kind of look at these things. So we add to cart. We have enter your city. Let's try test. Doesn't seem to do anything. Maybe check nearest shop. We are not delivering in your location yet. Okay. Let's check our cart here. So seems to just be a very simple application. Every time you add something to the cart, it just adds something over here. Let's look at what that is in Burp Suite. So it says, or let's actually intercept that when we add to cart. Oh, and it's not even performing a query. This is probably just some JavaScript here. That whenever we click the button, it just calls this function called add to cart. And I guess 3 is the index of this t-shirt. So anyways, that's not that interesting in that case. Let's look at these images. So we have a bucket called gigantic-retail. So just like in the other challenge, let's see if there are any hidden files in this bucket. So we can do GoBuster and dir to search directories. We'll provide this URL of the bucket. And we can do raft large words and provide extensions. So just like the other video, we can do log files, txt files, 7z, and zip to see if there are any backup or archives that shouldn't be there. So let's just enter. And we have a 403 error, probably because, let's see, if we were to access just the root directory of the bucket and we turn off intercept. Yeah, just access denied because we do not have the storage objects list permission. So let's blacklist 403, and 404 is just the negative status code by default. That's just when no file is found, although I don't think we will get a 404 anyways, but let's enter it. So while that's running, let's look at other parts of the application. We didn't check profile yet, so it's redirecting to the profile page. Okay, and here we are. please provide a valid image URL. I guess this is our photo here. Let's try test, fetch image. Curl error, cannot resolve host test. Where is it? It's probably resolving it here in the image URL. Yeah, cannot resolve host test. Can we do some sort of remote code execution? Who am I? Does not seem to work, although this image URL is very interesting. In fact, when we typed something in here, the URL parameter is right here in profile.php. So whenever I see a parameter called URL, the very first thing that I think of is server-side request forgery. So we can try to test that by, what I like to do is I go here, I'll create a web directory, and then I can spin up a simple HTTP server with Python. And then I can have ngrok. And so what ngrok will do is it will create a public IP address that redirects any traffic to whatever place that you want it to. So in this case, I have an HTTP server serving on port 80. So I want to create an HTTP server for ngrok and forward all traffic that goes through this URL to this local port here. So let's copy this and paste it. So URL equals this, and let's see if we get a hit. And we do actually get a hit. It says get /200 OK, and we can see it over here. So we've confirmed that we definitely have server-side request forgery. We can make the server request whatever URL we want it to. And that's a very serious vulnerability, because another thing you can do is query. You don't need to do HTTPS. You can do something like file. So let's see, this might be a Linux server. So I always start off with etc password. And if that doesn't work, then I'll test if it's Windows. You can test it by doing ping on the host. So if we do ping this IP address, we can see that time to live is 56, and that's indicative of a Linux system. So the time to live would be different for a Windows system, and it depends on what OS it is. And so if you go on nmap, you do sudo nmap-o for OS detection, and you put in this IP address. One of the ways that nmaps tries to see what OS it is by using this time to live. So we'll just let that run. OS detection actually takes a while, but anyways, we know that it's a Linux system because etc password worked. So looking at this, let's look at bin bash. That's the interesting entries. So we have root, which makes sense. But we also have this user Ayush, and this is not a normal user to have in Linux, of course. So let's see if we can get the SSH file, if the SSH is open. So let's try SSHing into this box. Is SSH an open port? Yes, it is. It is an open port. So let's see if Ayush has an SSH file in the directory. So we go to /home ayush.ssh and then ID_RSA. He does not have an ID_RSA file. Maybe authorized keys, and not an authorized keys file. So we need to somehow get access to this infrastructure. We know that it's in GCP. I mean, that was already provided to us, but we can also find that by doing who is on this IP address. So who is, and we see that it says Google Cloud. So that's another way that you would know. And it looks like -o finished. So what did it say? says Oracle VirtualBox. But anyways, we know that it is Linux. I was expecting it to actually know what it is from SSH, but anyways, let's try that. nmap-sc-sv, and then we can provide this. Let's try to fuzz the files in this IP address. So let's take this. And here we can see it, Debian. Let's try to go GoBuster, or we actually have a file here, opt sec lists. Was it under fuzzing? LFI. We can see Graceful Security Linux. So let's use that. Great. LFI-Graceful Security Linux. And let's use this file. So GoBuster dir-u, provide this -w, this file, and let's remove this part. And let's see what happens. Let's blacklist 200 and 404 because we're not interested in those. I would have expected it to find something. Let's see what's in this file. Etsy passwd. Let's instead try fuff like this and put the fuzz here. And let's filter based off of words. So we see 1005 is appearing quite often. So let's filter on words 1005. And this appears to be all the valid files that we can query in the application. So let's check out, for example, MySQL. Anyways, we can look at all these different files. I've already done it. There's nothing really interesting in any of these files. So knowing that it is in Google Cloud, let's try to access the metadata service. So let's curl this right here and provide the metadata service. So the metadata service can be queried using metadata.google.internal. So let's see what happens here. Could not resolve, oh, I misspelled that, metadata. Fetched content is not an image. We see compute metadata here. So let's do compute metadata. And doesn't seem like there's anything else. Let's do v1. Seems like it's not returning anything. Metadata v1 instance service dash accounts. And we are getting a 403 error. Your client does not have permission to get this URL from the server. Missing metadata flavor Google header. So this header here is used to protect compute instances, the GCP compute instances, from SSRF attacks. This is like their version of IMDS v2, of AWS's IMDS v2. So somehow we need to get around this. Now we can't just provide a header inside of this URL using the HTTP protocol. But there is a way to get around this if the application allows users to query a legacy endpoint. So if we go here, I have a lot of notes on my website on GCP, AWS, and several other services as well, such as Active Directory, Wi-Fi. And you can just see from searching. So if we go to GCP, penetration testing notes, and we see legacy, or maybe some insecure, you know what, I think it's best that I go to the table of contents here. Insecure metadata endpoint. So if the client has v1 beta enabled, you can get the access token without the metadata token, without the special metadata header. So let's try to curl this and see what happens. This is a legacy endpoint. So it's unlikely that it will work, but let's see. Looks like the legacy endpoint doesn't work. But there's one last thing that we could try, and that is the Gopher protocol. So if we look right here, if we have SSRF, we can check if the Gopher protocol is enabled. And in this query, we have the host header, the metadata flavor Google special header in the request. So when we do this curl request, before we do it actually, let's look at what it is in decoder. So we decode as URL, and once more. So this is what it looks like. We're curling the metadata service, and we're performing a GET request on this endpoint. Now, this may work because here, as you can see, we are providing this metadata flavor Google header. This header is used to let the compute instances understand that the request is coming from a trusted Google device. Well, we can trick it by using the Gopher protocol with this request. So if we copy this request, and if we're very lucky, because Gopher is a deprecated protocol, it was used for interacting with documents, distributing, searching, retrieving documents, but it has since been deprecated because it just doesn't support hypertext. It's a very old protocol that's not really used anymore. But you could still find it sometimes on legacy systems. So let's paste this in and see what happens. And it's going to take some time, so let's just give it a few seconds. So we can see that it returned some stuff. So we have compute metadata v1 instance. Let's try to get the service accounts. So we can do that with service-accounts because we want the credentials for one of these service accounts in the metadata service. This is very similar to AWS's IAM endpoint. So we can see that it returns just this slash. I should have added a slash right here. Let's wait once more. So now we have default and we have bucket viewer. Now bucket viewer is quite interesting. We did see a bucket in this application. Let's query this. So we'll go bucket viewer. And so when we get the credentials for this bucket viewer, let's export that and then perform a curl request on the bucket using the authentication credentials of this bucket viewer. So let's do export access token, and it should be here any second now. And so now we can do token. And so finally we get the access token of this bucket viewer. So what we can do is paste that in here. Of course, without all the spaces. And I should put this in quotes as well. Actually, we don't need this and quote here. That's why it's creating this. And so there we go. So now if you do echo $access token, we can see it's right here. So when you perform a curl request on this bucket, which we saw earlier, if we go back here into the shop and we open this image, we can see this is the bucket right here. Now when we queried the root directory, we got an access denied because we don't have the storage objects list permission. But given that we did just get the bucket viewer service account, from the name we can kind of guess that it probably has this permission on this bucket. So let's check that out. So we can do curl on this bucket. So we'll get an error. Now let's provide a header. We can provide an authorization, bearer, and then put in this access token. Oh, that was in here. Let's do this, paste this command in this terminal and do again. And we get authentication required.
A few moments later.
Oh, I think I know what's going on. So let me just copy this command. Yeah, it's a common case of the single quotes versus the double quotes. That took too long, but here we are. So what was going on is I was doing these curl requests, and it was literally using $T to perform these curl requests rather than double quotes. I've been so used to using single quotes because I'm dealing with a lot of AMD symbols like ampersands and special characters. So I used single quotes when I really should have used double quotes. So now we have the data here. So let's try to see all the different keys. So let's do grep-e and let's grep the keys here. And we want any kind of key. It's probably between 0 to 30 characters, or I'll say just 20. I mean, keys won't be that long. And let's see what we get here. So there are all these different files that we can access. User data is quite an interesting one. So let's go for user data. User data. And let's do flag.txt. And here we have it. Flag.txt is right here. And there's actually another key. If we go 0 to 30 on here, we can see there's user data.csv. So if we do user data.csv, we can then get this file. So there were multiple things that went wrong. First of all, the application is vulnerable. It allows users to input a URL, an arbitrary URL in this image URL parameter here. In addition to that, the Gopher protocol is still enabled. That protocol has since been deprecated, so it should be disabled, but I suppose this is some sort of legacy system. Thank you for watching, and I'll see you in the next video.